Okay, the Chamber of Commerce of a Florida Gulf Coast community advertises that area residential property is available at a mean cost of $125,000 or less per lot. Suppose a sample of 32 properties provided a sample mean of $130,000 per lot and a sample standard deviation of 12,500. Use a 0.05 level of significance to test the validity of the advertising claim. Okay, we have a hypothesis test problem here, and again we'll consider it a 5-step procedure. We want to set up the null and alternative hypotheses. Now, the Florida Gulf Coast community has made a claim that the properties are no more than $125,000 on average. However, we have a sample here where the sample provided a mean of 130,000. So seems like there might be a little evidence contrary to the claim, and we want to test it. What we'll assume, though, is that the average is less than or equal to the $125,000 as claimed by the community. And the alternative is basically the opposite to that. And we want to run the test to see if that $130,000 sample average is enough evidence to reject the null and show that the actual average of the properties is greater than what is claimed. So we'll see if that's true. Now, 130,000 is from a sample, by the way, so it's just a sample. It doesn't necessarily prove conclusively that the overall population average is greater than the 125,000. It'll all depend upon the variation, standard error, and the other issues of sample size and everything else sort of plays into that to see if the evidence ultimately that we have is strong enough to go and reject that null. The second step of the hypothesis test is to look at the sampling distribution. We'll have, in this case, a t-distribution. We'll be using a t-distribution because our sample size is 32, but the standard deviation is taken from that sample as opposed to having sigma, the population standard deviation. Now, the center of the distribution is the $125,000 claimed average. We have a level of significance of 5%. We're testing on the upper end in this case. This is a one-tailed hypothesis test. And we have a standard error. We'll go ahead and calculate that. That's the sample standard deviation divided by the square root of the sample size, 32. So if I go ahead and calculate that out, I get 2,209.71. Now, again, this is a t-distribution because I'm working with the sample standard deviation. And although 32 in some arenas is considered large, a lot of times to be safe, we use a t-distribution because that standard deviation is coming strictly from the sample. As I mentioned in the content portion of this module, planning values or estimates of sigma that use a lot more data or experience to create, that they're more reliable, we could go ahead and use the z-table. But in this case, the standard deviation is only coming from one single sample. And because that sample, in some sense, is small when it comes to producing maybe a very good estimate of sigma, then we're going to go ahead and use the t-distribution here. Now, in using the t-distribution, I have a sample size of 32, so I want to define my degrees of freedom. This is pretty much the same as it always was. It's n minus 1, and 32 minus 1 is 31. So I'm going to be looking in row 31 on my t-distribution table. And by the way, that can be found in Appendix B, page 920 in your textbook. The column, the upper tail area, is 0.05. So my t-value, my critical value for my test here is 1.696. So 1.696. Now I can create my rejection rule. I'm going to reject h sub 0 if my test statistic, which I'll calculate in a moment, is greater than or equal to the 1.696 critical value. My test statistic, of course, is the basically the t-score or t-value for my $130,000 sample average. So I'll take that and subtract the claimed amount that I'm testing against here and divide by the standard deviation of the sampling distribution, or the standard error, and I get a value of 2.26. So comparing that to the critical value of 1.696, 2.26 is greater than 1.696. So reject h sub 0. So I have enough evidence to prove. I can take an action now. I've proven something, that the average cost of the properties is greater than the claimed amount of $125,000. I have statistical proof that that is true. So I'm rejecting the null hypothesis and I'm proving the alternative, therefore. Again, a hypothesis test using the t-table is pretty much the same as using the z-table. It's just that in this situation I'm dealing with a standard deviation that might not be as accurate as a standard deviation coming from a very large sample or many large samples, or a lot of experience and other things that come together to produce something that's very close to sigma. Like I said in the content portion of this module, people hardly ever know exactly what sigma is, but when you have an estimate that's very, very reliable, you can look at a z-table or a normal distribution. But in this case, if the sample standard deviation comes from one single sample and that sample isn't very, very large, and then you're really better off using a t-distribution. And the actual 5-step procedure and the mechanics is very, very similar to what you've done before.